Chapter 1.4, Equations of Lines and Linear Models. Now earlier we took an equation of the line and were able to come up with 2 points and graph the line. Now they are going to give us a point and a slope, or maybe even 2 points, and ask us to come up with the equation of the line. For instance, if you have 2 points, first point we're going to call x1, y1. That's our given point. And then some other point out there on the line, whether we know it because they give it to us or because we know the slope and we can find it. And using the slope formula, y2 minus y1 over x2 minus x1 equals m. To solve that for y, we're going to multiply both sides by x minus x1. So what's going to happen is those are going to cancel. The x minus x1 is going to show up on the other side. So we get y minus y1 equals m times x minus x1. This is the way most of you have probably learned your point-slope formula. Now this book will go one step further. Go ahead and add y1 to both sides. So the point-slope form that the book gives us is y equals m times x minus x1 plus y1. Add this equation, or this formula, to your list of formulas that you're going to need to know for the quiz. So, a line with slope m passing through the point x1, y1 has an equation y equals m times x minus x1 plus y1, or y minus y1 equals m times x minus x1. This is what we call the point-slope form of a line, because you can look at it and you can see the point and you can see the slope. So, let's try one. Find the equation of the line that has a slope of 2/3, which passes through the point 4, -5. So, our point-slope form, we write it down. We're going to plug in slope is 2/3, so that goes in for m. We know our given point, this is x1, y1, so we're going to plug x1 in as 4, y1 in as -5. Distribute the 2/3, so 2/3 times x and 2/3 times -4. Combining like terms, so we've got -8/3 minus 5, which would give us 15/3, which would give us a total equation of y equals 2/3 x minus 23/3. Now, on my math lab, be careful. If they ask you to write your answer in point-slope form, you're going to stop right here. But if they ask you to go ahead and do SlopeIntercept form, which we learned about in the last module, then you will need to go ahead, distribute it out, and combine like terms. Okay, let's try it again. Write the equation of a line that has a slope of 2, so we know m equals 2, and passes through the point 3, -4. So that means x1 is 3, y1 is -4. So we're going to take our equation, y equals m times x minus x1 plus y1. Plug it in. So y equals, slope is now 2, times x minus the x value, which is 3, plus the y value, which is -4. This is point-slope form. Okay, so when they ask you to write it point-slope form, this is what they're wanting. SlopeIntercept form means let's go ahead and get it in y equals form. So distributing the 2, we get 2x minus 6 minus 4, or we get 2x minus 10. This is your SlopeIntercept form. Now, what if they ask us to find the equation of a line that passes through the points -3, 7, and 2, 5? Well, we don't have a slope, but from earlier you guys should be able to find the slope. How do you find the slope? y2 minus y1 over x2 minus x1. We'll just randomly come in here and say, well, the first point they give us is 0.1 and the second point is x2, y2. So that gives us 5 minus 7 over 2 minus negative 3, which gives us a slope of negative 2/5. Now we may choose either point. I usually just go with the first one, the negative 3, 7. So we get y equals m times x minus x1 plus y1. Plug in slope is negative 2/5. Plug in x1 is negative 3 and y1 is 7. Distribute that out. Now, to look at that, that's going to be negative 2/5 x minus 6/5 plus 7. Well, to do negative 6/5 plus 7, you have to remember that 7 is 7 over 1, and an LCD is 5, so we're going to rewrite 7 over 1 as 35 over 5. Now we're able to combine like terms, and we get y equals negative 2/5 x plus 29/5. Okay, let's do it again. This time write the slope-intercept form. Now remember, slope-intercept should say, hey, let's go ahead and solve it all the way out for y equals. So the first thing we're going to have to do is find the slope. Formula, y2 minus y1 over x2 minus x1. So we get negative 3 minus 7 over 2 minus 5. Now I know I probably switched it on you, went x1, y1, x2, y2, but you know what? It's the same thing as long as you're consistent and you call this the x from 1 and this is the y from the 1, and this is x from the second and this is y from the second. We'll get exactly the same thing. So we get negative 10 over negative 3, so slope would be 10/3. Now we're going to go into our point slope formula, y equals m times x minus x1 plus y1. So we get slope, which is 10/3, times x minus, I'm going to go ahead and use my x1, y1, 5, plus 7. So y is equal to, distributive property says 10/3 minus 50/3 plus 7. Well, let's come off to the side. Negative 50/3 plus 7 over 1. We need an LCD of 3, so that's negative 50 plus 21 over 3. So we get slope, or y equals 10/3 x, negative 50 over 3 plus 21 over 3 would also give us negative 29 over 3. This is slope-intercept form of the line. Now, slope-intercept form, we've talked about that, but let's go back and review that again. The line with slope m and y-intercept b is y equals mx plus b, just like our linear functions were last model. If you are given point 0b, watch what happens if you plugged it into your point slope form. You don't know a slope, but your point becomes 0b, which simplifies to give us y equals mx plus b. Okay, that's another equation that you need to add to your list that you're going to have to know for the test. Now, let's go a little bit different this time. I'm giving you the equation, and I'm asking you for the slope and the y-intercept. Well, let's stick this up here so we don't forget. Y equals mx plus b. The number in front of the x is the slope. The other number is the y-intercept. So y equals, we can look at that and say, hey, slope is 3, y-intercept is negative 5, or we could say it's the order pair 0, negative 5. But what about that one? Slope is not 2 because that's the number in front of x. Remember, slope-intercept has to be in the form y equals. So the first thing we're going to do on this one is subtract 2x from both sides. So we get y equals negative 2x minus 4. Now we're ready to pull off slope and y-intercept. Slope would be the number in front of the x, which is negative 2. Y-intercept would be the other number, which is negative 4. Let's try this one. X plus 2y equals 12. If you're looking for slope and y-intercept, you need to get it in y equals form. So we're going to do minus x. So we get 2y equals negative x plus 12. Divide by 2. So we'd get y equals negative x over 2, which I'm going to rewrite as negative 1/2 x, plus 12 over 2 would be 6. Once we get it in y equals form, then we can eyeball it and see that the slope is negative 1/2 and the y-intercept is 6. Now it's real good that you know how to do the y equals form, because if you choose to graph this on your calculator, you've got to get it in y equals form to use your calculator. Okay, one more. 3x minus 4y equals negative 9. So first thing we're going to do is subtract your x's off. So we get negative 4y equals negative 3x minus 9. Divide both sides by negative 4. So we get negative 3x over 4, which is 3 over 4x, minus 9 over negative 4, which is going to be plus 9 over 4. So slope is 3/4, and y-intercept is 9/4. Okay, let's do it the other way. Find the equation of the line that has a slope of negative 1/4 and a y-intercept of 5. Well, slope is negative 1/4, which means m would be negative 1/4. Y-intercept is 5, which means b is 5. So we just do straight substitution. Y equals negative 1/4 x plus 5. Okay, try another one. Write the slope-intercept form, that's y equals form, of a line that has a slope of 2/3, m equals 2/3, y-intercept is 6, which means b is 6. Slope-intercept says, hey, we know the slope, we know the y-intercept, let's plug it in. Y equals 2/3 x plus 6. That's our equation. Now, sometimes we'll talk about standard form. An equation of a line is in standard form when it's written as ax plus by equals c. A, b, and c are usually constants. A is usually positive and not a fraction. And the reason we do this is when we're solving for the intercepts, it's a little bit easier. So, whenever they say standard form, x's and y's are on one side, numbers are on the other. So, 2x plus y equals 8. That would be standard form. So if we're looking for intercepts, remember this is let x be 0, find y, that's the y-intercept. Let y be 0, find x, that's the x-intercept. These are pretty easy substitution. If x is 0, we get 2 times 0 is 0 plus y equals 8, so we know that y is 8. If y is 0, then we just get 2x equals 8, divide by 2, so x is 4. That gives us our points over 0 up 8, 8 over 4 up 0. So see, that one was fairly easy to graph by hand. Okay, let's do another one. This one's in standard form. If they ask us for intercepts, we're doing x is 0, find y, y is 0, find x. If x is 0, 4 times 0, so we get 0 minus 3y equals 12, which means negative 3y equals 12. Divide both sides by negative 3, so y is equal to negative 4. If y is equal to 0, 4x minus 0 equals 12. 4x is 12, divide by 4, so we know that x is 3. Fairly easy to get our points if it's in standard form. Over 0 down 4, over 3 up 0, connect the dots, And there's your equation. Now, horizontal lines and vertical lines. Remember we talked about constant functions. An equation of the horizontal line with y-intercept b is just y equals b. An equation of the vertical line with x-intercept a is x equals a. So, y equals 4, horizontal line through 4. X equals -2, vertical line through -2. Now what about this one? Find equations of the horizontal and vertical lines passing through the point 4, 7. Now think about this for a second. 4, 7 would be over 4 up 1, 2, 3. Over 4 up 7. Well, a vertical line would be right through here, which if you notice every point on that line has an x value of 4, so that would be your equation, just x equals 4. A horizontal line would be this line right through here, and if you'll notice, every point on that line has a y value of 7, so that would be that equation. So there's your horizontal line, there's your vertical line. Oops. Now, slopes for parallel lines and perpendicular lines. Parallel lines have the same slant, therefore they have the same slopes. Those two lines will run side by side and never touch. They are parallel lines. Whatever the slope of the blue line is, the red line has the same slope. Perpendicular lines have slopes which are negative reciprocals. So if the slope of the blue line is 3/2 and the red line is perpendicular to that, then the red line would have a slope of -2/3. So now let's use this with what we've already learned. Find the equation of the line that passes through the point 2, -1 and is parallel to the line 3x plus 5y equals 2. Now remember, to write the equation of a line, you need a slope and you need a point. If the point's the y-intercept, then we can just use our slope-intercept. If it's not the y-intercept, then we're going to use point slope. Either way we go, we've got to know a slope. Well, they tell us that it's parallel to this line, which means it's going to be the same slope as that line. So if we have 3x plus 5y equals 2, how are we going to find the slope? Solve for y equals. Subtract 3x, subtract 3x, so we get 5y equals -3x plus 2. Divide by 5, divide by 5. So y equals -3/5x plus 2/5, which means the slope of this line is -3/5. So we're going to use the slope of -3/5 and the point 2, -1. So here we go, y equals m times x minus x1 plus y1. So y equals -3/5 times x minus the x value 2 plus the y value, which is -1. Distributive property, -3/5 x plus 6/5 minus 1. But remember, 1 is the same as 5/5. So we get y equals -3/5 x plus, we've got 6/5 minus 5/5, which is 1/5. So there is the equation that passes through the point 2, -1 and is parallel to 3x plus 5y equals 2. Okay, let's do it again. Find the equation of the line which passes through the point 5, 3 and is perpendicular to 4x minus 9y equals 11. Now remember, the parallel and the perpendicular, that's how we're going to find our slope. So we're going to take the equation 4x minus 9y equals 11, get it in y equals form, so we get -9y equals -4x plus 11. I guess we could have gave you some easy ones. Y equals 4/9x plus a negative 11 ninths. I'm just going to call that minus 11 ninths. So the slope of this line is 4 ninths. Now, because it's perpendicular, we're going to use a slope of negative 9/4. And we're going to use the point 5,3. So y equals the slope, which is negative 9/4, times x minus the x value plus the y value. So y equals negative 9/4 x plus 9/4 times 5/1 would give us 45/4 plus 3. Well, 3 is 3/1, which is also, with an LCD, 12/4. So I'm going to go ahead and call that 12/4. So we get negative 9/4 x plus 57/4. That would be our equation that passes through the point 5,3 and is perpendicular to them. Okay? Linear models, discrete data points can be plotted, and the graph is called a scatter diagram. Now, this is really useful when you're analyzing trends in data. So if we took these data points and plotted them on a graph, we would get something that looks like this. Now, you notice that's pretty much a straight line. Well, to find a linear model, or if it is a linear model, we can pick any two of those points and do it like we did earlier. Take your y2 minus y1 over x2 minus x1, find the slope. In this case, we know the y-intercept, so we could do our slope-intercept form and come up with the equation f of x equals 18x plus 264. Now, part C says, predict the cost of Medicare in the year 2010. Well, what we did, let me back you up for a minute. What we did is we went through and said, well, let's let this be 0, and let's let this be 1, and let's let this be 2. And the way you'll see that worded is where x is the number of years since 2002. That just makes our graph a little easier instead of having to go out to the year 2002. So, if we're looking for the cost in 2010, 2010 corresponds to x equals 8. So we're going to take 8 and plug it into our linear model, 18 times 8 plus 264. So the cost in 2010 will be $408 million. Now, when a linear function is used to approximate data, it's called linear regression. We're going to use our calculator to do, we call it the line of best fit, and we use the least squares method. It's real ugly if you do it pencil paper, but it works really well. If the data is exactly linear, remember we said if you have a line, it doesn't matter which 2 points are on the line, then it really doesn't matter. This is when we want to approximate data. So what's going to happen is we may have some data points that are just like this, and depending on if we would have picked these 2 points, that line may have looked like this. Or if we would have picked these 2 lines, it may have looked like this. So depending on which of the points we pick would actually determine which line fits it best. So anytime we're approximating the data, we're going to use our calculator to find that regression line, which is the best fit line. Okay, your calculator is going to give you a correlation coefficient, which tells us how closely the model matches the data. If you get an R value of 1, then it is an exact linear fit. Every point is on the line, and it's not a problem. Okay? If R is -1, that means it's still a perfect fit. However, it's a negative correlation, so that means that line would have a negative slope. If R is somewhere between 0 and 1, that means it's a positive correlation, so it's going to have a positive slope. The closer it is to 1, the better fit it is. The closer it is to 0, there is no fit. Okay? And then same thing back for the negative direction. Anything between 0 and 1, or between -1 and 0, means it's a negative slope. There is a negative correlation. The closer it is to -1, the better of a fit it is on that linear data. Okay? And if R is 0, there is no correlation. It's nowhere close to being linear. And what you're going to have basically is some little group of points that just sit, and it's going to be hard to find a line that fits most of those data points. Okay, you ready? The paired data below consists of the test scores of 6 randomly selected students and the number of hours they studied for a test. By using linear regression, find a function where x is the number of hours studied and y is the score on the test. Use this function to predict the score on the test of a student who studies 8 hours. Round to the nearest tenth. So if we wanted to go through and make a scatter plot of all the data, we could. All right, here we go. First thing we want to do is, if we want to do a scatter plot on our calculator, is we go to Stat, and we're going to Edit, and we're going to put the values in there. Now, if we have values in there, what we can do is come up to where it says L1 and clear, press Enter, and that clears list 1. Come over up to the top where it says L2, hit clear. Now, don't hit delete, or it deletes the whole column. So L1 would be 5, 10, 4, 6, 10, 9, pressing Enter in between each point. L2 would be 64, 86, 69, 86, 59, and 87. When you get your data points in there, if you want to look at the picture, what you're going to do is go second y equals. That's where it says stat plot. You're going to choose 1 because we stored them in 1. We're going to hit Enter to turn that graph on. And then to graph it, now if I hit graph right now, you wouldn't see anything because our graph is from -10 to 10. But if you will hit Zoom and arrow down until you get to Zoom Stat, that will find us a window that shows all of those data points. Now, does that look very linear? Probably not. Okay? Now, how do you find that line of best fit? We're going to go back to Stat. This time we're going to slide over to Calculate. And we are going to go down to where it says Linear Regression number 4. We're going to press number 4 to choose Linear Regression, and then we're going to hit Enter again, which says y equals ax plus b. A is the number in front of x squared, in front of x, so it's 1.066. B is like the y-intercept, which would be 67.35. Okay, so our linear regression would be 1.1x plus 67.3. Okay, now you notice the R. If your calculator does not have an R on there, and sometimes you won't, what you do is you go to Second Catalog, which is a catalog of all the things in your calculator. Scroll all the way down until you get to D for Diagnostics. And you're going to choose Diagnostics On. Hit Enter to select On. Hit Enter again. Now when you go back and do your regression, if you didn't get an R, you will now. But anyway, R is 0.22, which is pretty close to 0, which says there is really no correlation at all. Now, the previous question said, use this to predict the score of a student who studies for 8 hours. That means X is 8. So we're going to take 8, plug it into that formula, which says supposedly if it were linear, the person who studies 8 hours. Another example. The table lists the average tuition and fees at public colleges and universities for selected years. Find the equation of the line that best fits the data. Same thing. Let X be the number of years since 1985. So we're going to say this is 0, this is 5, this is 10. From 1999 to 1985 would be 14. From 2004 to 1985 would be 19. So these are the X values that we're going to use in our calculator. Okay, so we're going to go in here. We're going to go to Stat. We're going to hit Edit. We're going to come over here. Let's go up to L1 and hit Clear. Press Enter. Go over to L2. Press Clear. Hit Enter. Now we're ready to enter the data. So we had 0, 5, 10, 14, and 19. Come over to L2. And we're going to do 1242, 1809, 2860, 3356, and 5132. Now, once we get them in there, we're going to go to Stat. We're going to slide over to Calculate, and then we're going to choose option number 4, Linear Regression. Pressing Enter, that tells us that the slope, or A, is 198.5, and that the B is 974. We found the line of best fit, which would be, if you want your calculator to stay on the screen while you're writing, what you would do is on your calculator, right-click, go to Options, and do Stay on Top. This way we're going to get a calculator that stays on when we're writing. So our equation would be y equals 198.5x plus 974.3. So when it says estimate the tuition and fees in 2006, well, first thing you've got to do is do 2006 minus 1985, which would give us 21. So for this problem, x is going to be 21. So we get y equals 198.5 times 21 plus 974.3. So we've got 198.5 times 21 plus 974.3, which says that we would expect in the year 2006 the tuition to be $5,142.80. Now, you are ready to complete section 1.4 of homework on my Math Lab. Good luck!